Hello everyone, welcome to the second lesson on how to consider all cases and reduce rework. Now in this lesson, I'm going to talk about questions where you need to consider a lot of scenarios before coming to the conclusion or before finding the answer. Now in most cases what I've seen is students, while finding out the cases, do not follow a methodical approach. They randomly try to look for patterns, and that basically increases a lot of work, and you go to and fro before either coming to the answer or wasting a lot of time. So I'm going to basically show you that to be able to do well and solve the question, these kind of questions where all cases are considered, what you need is to follow a methodical step-by-step approach. Okay, if you're methodical, you will definitely be able to get the answer very quickly. Now, a disclaimer here. Trying to become methodical takes some time. You don't expect that after seeing just one question, you will be able to think methodically. Okay, you need some practice. You need to put in effort in each and every question that you solve, and over a period of time, you'll definitely be able to solve questions in a step-by-step manner. So what I'm going to do here is I'm going to take a question once again, and here's the question in front of you. I'm going to show you how students usually solve these kind of questions and where do they falter, because of which the amount of time that they take to solve the question increases is more than 2 minutes, or maybe they are not even able to solve this question. Okay, so let's start by reading the question stem first. Okay, and the approach that I'm going to show you here would be an approach which is usually used by students. Okay, so what they usually do is, most students do is they start off by first of all reading that the question stem, which says that n is a positive integer between 1 and 100. So either you write that down in the word form, or you write it the way I've shown here. Okay, the next information that is given in the question is that it has exactly 6 factors. So we jot it down, and it's ideally recommended that you jot it down. So I'm assuming most students do that. Okay, and we finally write down what is being asked. So we need to find out how many values of n are possible. Okay, now at this point of time, what most students do is they jump into solving questions, solving the question. Okay, they don't focus on the fact that we are looking for 6 factors and how should we use this information to figure out a methodical approach to solve the question. So as far as defining the methodology is concerned, they do not look for the right approach. They should ideally ask themselves, hey, what's the right approach to solve the question, or ideal approach to solve the question. Okay, what they do is they just take random values of n and try and see how many of these actually fit in the criteria that is given in the question. So how many of them actually have 6 factors. And believe me, this is a very poor and very wrong approach. Okay, now ideally what I've seen is there are 2 types of approaches that students use which are incorrect. Let me talk about them one by one. Now, those of you who know the formula of total factors, okay, and you focus a bit on 6 factors, what you do is you start taking numbers randomly. So for example, you take n as 6, okay, you prime factorize it and write it as 2 to the power 1 times 3 to the power 1, and then you find out the total factors as 4. And you see, hey, it's 4, I need 6, so this might not be my, this cannot be the answer. Then you take some other number, say you take 8. Here also you see 8 is 2 cubed, total factors is 4, you discard it. Then maybe with you try 9, 10 if you want to, or you jump to 12, for example. And here you see, hey, 12 is 2 squared times 3 to the power 1, total factors is 6. So 12 is definitely one of the numbers. And at this point, if a student is slightly logical, then he will be able to discover a pattern, understand a pattern that he's looking for numbers where the power is 2 and 1. So he'll be able to see that, and maybe after this he may start writing the numbers in that form only. So he may look at 20, where again you have 2 square 5 to the power 1, 2 prime numbers, one with power 2, one with power 1, and this way he may start finding out the values and maybe end up at, say, 2 square times 23 to the power 1. Okay, but and he may stop here also, or he may continue looking for some other values. But I'm sure by now you must have understood that this is a very tedious approach. Okay, I'm not being methodical here. I just by writing down, once I start writing down values, I'm wasting my time. That's number 1. Number 2, I'm looking for a pattern which I may or may not get. In this case, we were able to see one pattern here, and we try to use that to come up with some values. Okay, and maybe even if you find out all the values, it's still very time consuming, and there is a high chance that you might miss some cases. Okay, and if the GMAT wants, they can even trick you by giving an option like none of these. So say for example you solve all of them and you come up with an answer, say 13, 14, and since there's a none of these here, you might think, hey, the answer has to be none of these, so let me mark it, and that might be incorrect. Okay, so this is not the right approach to solve a question, because you're not doing anything, you're just randomly moving and trying to find out the answer, looking for a pattern. Another approach which I've seen students use, and this is again a very poor approach, and this is used by students especially who are not who fail to understand that you need to use the total factors formula. So what they do is they also start by looking for numbers, but they waste more time by actually counting down the factors. So they take 6 and they count 1, 2, 3, 6. So 4 factors. So this is not the answer. Then they go to 12. They literally count 1, 2, 3, 4, 6, 12. Hey, so this might be one of them. And I'm sure you can understand that this method is even more time consuming and poor than the approach one, because here you're literally moving randomly, you're clueless, and in most of the cases what will happen is you'll end up marking the answer randomly, because you cannot check all the cases till 100, right? So here also it's very time consuming, and once again you might miss a lot of cases, still end up marking the answer as E. So this is where you're doing a lot of work. And this is what through this question I wanted to show you, that you can avoid all these things if you actually take a step back and do not jump into solving questions directly. You should ask yourself, see, in GMAT, the questions that are given, they always have a methodical approach to solve the question. They will not ask you to do a lot of grunt work and basically randomly look for values. They don't ask questions like that. Okay, so let me now talk about the best way to solve the question. How can we methodically solve this question? See, I need to find out the cases. That's there. But is there a right way to do it? So what I'm going to do is, I'm going to tell you how I would have solved it. Once again, these are the information that I would have written down, but then I would have focused on 6 factors. And I would have asked myself, okay, I need to find out the total factors. Now, what is the formula for total factors? So if I prime factorize a number, you know that whatever the number is, if I prime factorize it and write it in this form, where these are the prime numbers and these are the powers, I know that the total factor for this kind of a number is a plus 1 times b plus 1 times c plus 1, where a, b, c are the powers. We know this. Okay, now I know that this total factors that is given here, a plus 1, b plus c plus 1 formula, this is actually equal to 6. So what I'm going to do is, I'm going to equate it to 6. Now you might say, hey, I don't know how many prime numbers does n have. And I'll say, that's fine, I don't know. But I know the formula will look something like this. I also know that my left hand side, that is a plus 1, b plus 1, c plus 1, these are all product of integers, okay, because the powers are all integers. So if I have a 6 here and it's a product of some integers, I can break down 6, okay, and I can manipulate 6 and then try and figure out what can be a, b, c, because if I can do that, it will be much more easy for me to get my answer. And let's see how. This is where we'll go to the third step and try to calculate the final answer. So the first case could be, you could say yourself that, okay, it's quite possible that the right hand side 6 can be written as 6 times 1 times 1 times 1 and so on, because that will give you 6. Now what you can do is, you can start equating. So you can say a plus 1 is equal to 6. If a plus 1 is equal to 6, then a will be 5. If b plus 1 is equal to 1, b will be 0. If c plus 1 is equal to 1, c will be equal to 0, and so on. So the rest of the powers will all be 0. And what that means is, you knew that n is equal to p1 to the power a, p2 to the power b, p3 to the power c. You put zeros here. And you know that prime number to the power 0, these will all give you 1. So these are all irrelevant. Ultimately, if a plus 1 is equal to 6, then that means n is nothing but p1 to the power 5. Now see, I have come up with a methodical way to solve the question, and I know exactly what n can be. Now if I can put values, and I know what kind of values I need to put, I need to just look for prime numbers. I need to put a prime number here and find a value of n that lies between 1 and 100. That is all that I need to do. So I'll take p1 as 2. If I take p1 as 2, 2 to the power 5 is 32, so that's one value that I can consider. If I take p1 as 3, 3 to the power 5 is 243, and I need values between 1 and 100, so I can avoid this value. So I can say when I have 6 times 1 times 1 and n is p1 to the power 5, then in this case there's only one possible case, that is 2 to the power 5, 32. Okay, so see, it was very easy for me to find out the answer very quickly. Now the next question you should ask yourself is there any other possible way of breaking down 6? Okay, and you know that 6 is 2 times 3, right? So it is quite possible that there's another case, and 6 cannot be broken down any further, so I'm sure that there'll be no other case possible. But this is the second case which is possible, which is 3 times 2 times 1 and so on and so forth. Again, rest of them will also be 1. So I'll say a plus 1 is equal to 3, where I'll give a is equal to 2. B plus 1 is equal to 2, where I'll get B as 1, and C plus 1 is equal to 1, where I get C as 0. So I know that n is nothing but p1 to the power 2 times p2 to the power 1, and the rest of the powers will all be 0. So I don't need to worry about it. Now this is here where things get a little tricky, and this is an important learning here. Now some of you may have been able to do this also, but you may falter if you do not put values methodically to find out the answer, to find out the cases. And let me tell you what I'm talking about. Ideally, what you should do is you should start with the smallest case. So for example, I'll put p1 as 2 and p2 as 3. Okay, and here I can see if I put p1 as 2, then 2 square gives you 4 times p2 to the power 1, which is 3 to the power 1, which gives you 3. So you're getting 12. Now when I look for the next value, what I'm going to do is I'm going to fix one of them. I'm not going to change both of them, because I do that I'll lose track of what values I've taken, what I haven't. So I'm just going to fix one and increase the other. So the next prime number that is possible is 5, 2, 5. So I'm fixing 2, I'm changing the other one to see till where can I go. Now notice again you'll get 4 times 5. Again fix 2, move on to the next one. You'll get 4 times 7. Okay. Now after this you should be able to notice a pattern. Again, you don't need to write all of them down, because then again you'll waste a lot of time. Here what you need to notice is that you're basically taking 2 times some prime number, and when you're multiplying it, you're getting 2 square, 4 times the prime number. And you know 4 times this prime number should be, this is your value of n, and this value of n should be less than 100, right? So you can say 4 times whatever prime number that I'm multiplying should be less than 100. After multiplying with the second prime number, the value should be less than 100. So this directly tells you that your prime number should be less than 25. And see, I did not write down all values. Once I know my prime number should be less than 25, I know P2 can take these values: 3, 5, 7, 11, 13, 17, 19, 23. Total 8 values. So if P1 is 2, if I keep P1 as 2, then P2 can take 8 values. So there are total 8 possible cases out here when P1 is fixed as 2. Now once I have found out all the cases where P1 is 2, I'll now move on to the next case, where I'll say, okay, all cases with 2 is over. So now let me make P1 3. So now I'm increasing this. So notice now I'm changing this now because I've done, I'm over with all this. Now I'll say, okay, if this is 3, this is 2, what will happen? So I'll get 9 times 2. Here also you could say, okay, I'm looking for 9 times something. So ideally you should be able to come up with an answer that I can go till 9 times 11, right? So you can have 3 times 5, 9 times 5, 9 times 7. I'm not writing down the values because it's not necessary. And you will say, okay, 9 times 11 is 99. I cannot go any further, and you can check that I haven't written down the value. But if you keep P2 as 13, then that will become more than 100, and n cannot be more than 100. Now all cases with 3 is over. Then you go to 5, 5, 2. Okay, then you'll say 25 times 2. Okay, if 25 times 2 is possible, then 25 times 3 will also be possible. Now the next possible case is when I take 5 times 7. Now if I take 5 times 7, then that would be greater than 100, and I cannot do that. Okay, so that case will get discarded. Then I'll go to 7, I'll see 7 times 2 is 98. I cannot do 7 times 3 there because that will exceed 100. And from here you should be able to understand that you don't need to go to 11, because after 7 that's the next is 11, and 11 square itself is more than 100. So that means these are the only cases that are possible. And see, the reason I was able to do it properly was because I knew I'm moving in a methodical manner. I am testing out all the cases easily, so I'll never make a mistake here. So total with P, when P1 is 2, there are 8 cases. Here I have written, you can count it down, 1, 2, 3, 4, 5, 6, 7 cases. And the previous, in case 1, we had 1 case. So total number of cases is 1 plus 8 plus 7, which is 16. So thus the correct answer in this case will be option D. So I hope this is perfectly clear. This is a difficult question, especially if you don't know how to manipulate and write these values, you will end up making a mistake. So there are 2 to 3 learnings here. One is, when you read the question, don't jump to the step 3 without figuring out how to solve the question. Step 2 is very important to define the methodology. Second is, it's very important for you to break down the cases as shown here. You should know how to use the total factors formula and how to use the number 6 to create different cases. So you should, if you want, you should first write down the cases, case 1, case 2, and then find out all the values if you want. Third is obviously writing it in a methodical manner. Okay, if you don't write it in a methodical manner, fixing one and then changing the other, then you will end up missing out a lot of cases. Okay, so the final takeaway here is that, see, a strong conceptual knowledge is really, really important. If you don't know the formula of total factors, you will not be able to even know what to do here. You may end up using a very wrong approach. You may end up finding the values manually, which is, again, as you can understand, will never help you solve questions under 2 minutes. The second thing is obviously the methodical approach, because as I showed you, if I'm doing it methodically, the chances of making a mistake reduces because I'm writing down each and every case properly. And of course, this was a difficult question. So you might even take 2 minutes, 10 seconds to solve it, but you'll definitely get the answer here without making a single mistake. So, and this is a thing which I told in the starting also, that building this skill of using a methodical approach, finding out cases, is a skill that takes some time to develop. And when I say some time, what I mean is you just need to practice and apply it in each and every question. Over a period of time, after solving 50, 70 questions, okay, you will see that you are automatically, intuitively, you are able to think in the way, in a methodical way. So that's it from my side. I hope this lesson was very useful. Now we'll be providing you with 2 questions. Try and solve them and see if you can create the cases methodically and get to the correct answer. All the best.